In this video, we discuss miscellaneous exercise based on chapter 9. The first question is show that the sum of m plus nth. First question is show that the sum of m plus nth means a m plus n and m minus nth term. Sum of m plus n and m minus nth term is equal to twice the mth term. Twice the mth term. We have to show that sum of m plus n term and m minus n term is equals to twice of mth term. So firstly we find a m plus n, and the formula used is a into r raised to the power n minus 1. So the first term is a, common ratio is r, and total number of terms is m plus n. So m plus n minus 1. This is the value of m plus nth term, a m plus n. The value of m plus nth term is a into r raised to the power m plus n minus 1. Then we find the m minus nth term, a into r raised to the power n. The value of n is m minus n. So n minus 1, a into r raised to the power m minus n minus 1. This is the m minus nth term. Now we put the value. We put the value in LHS. So the LHS which we have to prove, a m plus n plus a m minus n, and the value of a m plus n is a into sum of m plus nth and m minus nth term is equal to twice the mth term. So the value of a m plus n, a into r raised to the power m minus m plus n minus 1 plus a into r raised to the power m minus n minus 1. Sum of, but this is the AP, not GP. This we have given the terms are in AP. The terms are in AP. So m plus nth term of AP, a m plus n equals to a plus n minus 1. The value of n is m plus n minus 1 into d. Then we calculate a m minus n. So a plus m minus n minus 1 into d. Then the value of LHS is a m plus n plus a m minus n. Then put the value of a m plus n. This is a plus m plus n minus 1 into d, and m minus nth term is a plus m minus n minus 1 into d. A plus a, we get 2a. And from these two terms, d is taken common. So m plus n minus 1 plus m minus n minus 1 into d plus n minus n cancelled and 2a plus m 2m minus 1 minus 1 minus 2 into d. So 2a plus, taking 2 as common, we get m minus 1 into d, and throughout we take 2 as common. So there comes a plus m minus 1 into d, and this is the mth term. A plus m minus 1d is written as twice of am, mth term, and this is RHS. So we have to prove that am plus am minus n equals to twice of n. So by solving LHS, we get the result twice of am, 2 times of mth term, means 2 into a plus m minus 1 into d. So we get the result Let us see question number 2. Question number 2. The sum of 3 numbers in AP is 24. Let 3 numbers in AP be a minus d, a and a plus d. 3 numbers in AP is taken as a minus d, a and a plus d. Now we have given that the sum of 3 numbers is 24. Their sum is 24. Means a minus d plus a plus d is equals to 24. Minus d plus d cancelled and 3a equals to 24. And the value of a comes to be 24 upon 3, that is 8. So we get the value of a equals to 8, and also it is given that their product is 440. A minus b into a plus b. This is equals to 440. We have given that the product of 3 terms in AP, and 3 terms in AP is taken as a minus d, a and a plus d for the convenience of calculation, and their product is 440. We put the value of a. The value of a is 8, so 8 minus d into 8 into 8 plus d, and that is equals to 440. A minus b into a plus b. 8 would be written outside. A minus b into a plus b. We get a square minus b square equals to 440. Then 8 square is 64 minus d square equals to 440 divided by 8, which comes 55. Then 64 minus 55 equals to d square, and the value of d is 9, and d comes to be plus minus 3. So we had to find 3 numbers. So by taking a equals to 8 and d equals to 3, when a equals to 8 and d equals to 3 plus 3, then the first number a minus d equals to 8 minus 3, which is 5. The second number a equals to 8, and the third number a plus d equals to 8 plus 3, that is 11. So the three numbers we get 5, 8 and 11. And when we take a equals to 8, when a equals to 8 and the value of d equals to minus 3, then the first number a minus d, 8 plus 3, that is 11. Second number a is 8 and third number a plus d is 8 minus 3, that is 5. So 11, 8 and 5, the three numbers in A. Question number 3. Let the sum of n, 2n and 3n terms of an AP. Let the sum of n, 2n, 3n terms of an AP be S1, S2 and S3 respectively. Sum of n terms is S1. So S1 equals to A plus L minus 1 into D. This is the sum of n terms of an AP is given S1. So S1 equals to L by 2 into 2A plus N minus 1 into D. First number equation. And S2 is the sum of 2n terms of an AP. S2 equals to sum of 2n terms. So 2n by 2, 2 into A plus 2n minus 1 into D. This is second number equation. Sum of 2n terms means at the place of n there is 2n, and the sum of 3n terms is S3. S3 is the sum of 3n terms. So S3 equals to 3n by 2 and 2a plus 3n minus 1 into D. This is third number equation. And then we have to show that S3 equals to, show that S3 equals to 3 into S2 minus S1. S3 equals to 3 times of S2 minus S1. So we solve the RHS. The RHS is 3 into S2 minus S1. 3 as it is, put the value of S2. S2 is 2n by 2 and 2a plus 2n minus 1 into D. Then minus S1. The value of 2a plus n minus 1 into d. We put the value of S3 and S1. The value of S2 is 2n by 2, 2a plus 2n minus 1d, and minus the value of S1 is n by 2 and 2a plus n minus 1d. So 3 as it is, and 2n by 2, 2n by 2, this 2 and 2 gets cancelled and we remove the bracket. So n multiplied by 2a, we get 2an plus n and b multiplied by 2n. So 2n square b and minus nd. We remove the bracket by multiplying these terms by n, and this term is also multiplied by d. Minus n by 2 multiplied by 2a. It comes n into a. N into a plus n by 2 into nb. So plus minus and n square b upon 2. Then minus plus n by 2 into d. So 3 times of 2an minus an, we get an. 2an minus an, we get an. Plus 2n square d minus n square d, we get plus n square d. Then minus nd and plus nd by 2, plus nd by 2, nd by 2 and minus nd. By taking LCM, we get nd minus 2 nd, that is minus nd by 2. So after solving these two values, we get minus nd by 2. And this can be written as, by taking LCM, 2 multiplied by an, 2an plus 2n square d minus nd and whole upon 2. Taking LCM, 2an plus 2n square d and minus nd. From all these three terms, we take n as common. From all these three terms, n is taken common. So 3n by 2. Here we get 2a plus we have taken n as common from these two terms. So it remains 2nd and minus 2nd and minus d. N is taken common. 2nd minus d. S2 minus S1. The value of S1 is L by 2, 2a plus n minus 1d. So minus Na minus plus minus and minus plus. 2an minus an plus n square d, 2n square d minus n square d by 2. So 4n square d minus n square d. Here we get 3n square d upon 2 and minus nd and plus nd by 2 minus nd by 2. Then here comes 3n square d. 3n square d and minus nd. N is taken common from the numerator, so 3n by 2 and it remains 2n and plus here remains 3nd minus d. So 3n by 2, 2a plus. From these two terms d is taken common, so 3n minus 1 into d. And this whole expression is equals to S3. So we get the result. S3 is the LHS. S3 is the LHS. So after solving RHS 3 times of S2 minus S1, we get the LHS S3. So we can say that LHS is equals to RHS. So this proves the result. Let us see question number 4. Find the sum of all numbers between 200 and 400. Find the sum of all numbers. Question number 4. Find the sum of all numbers between 200 and 400 which are divisible by 7. So the first number between 200 and 400 which are divisible by 7 is 210. 210 is divisible by 7. Then the another number which are divisible by 7, that is 270. 270 is also divisible by 7. Then the third number we get 224, which is also divisible by 7. Then plus dash dash. The last number before 400 which are divisible by 7. The last number before, just before 400, the number just before 400 which are divisible by 7. That is 7. So 7 into 3, 355 and 357. 357 before 400, the number which are divisible by 7. Before 400, the number which are divisible by 7. So 7 divided by 400. So 7 5 ja 35, 5 carry 50, 7 7 ja 49. Remainder comes to be 1. So 399. When divided by 7, we get 7 5 ja 35, 4 carry 49 and 7 7 ja 49. It goes by 57. So the last number just before 400, which are divisible by 7, is 399. So between 200 and 400, the last number be just before 400, which are divisible by 7, is 399, and the first number is 210. And we have to find the sum of these numbers. So the first number A is 210, common difference D is 7, 217 minus 210, and the last term AN is 399. So first we find the value of n, the number of terms. So the formula used, AN equals to A plus n minus 1 into D. The value of AN is 399. The first term is 210, and n we have to calculate, and the value of D, common difference, is 7. 210 will go on left side. So 399 minus 210 equals to 7 into n minus 1. Here we get 9, 8 and 1. 189 equals to 7 into n minus 1. Then 189 divided by 7 equals to n minus 1. And n minus 1 equals to 27, and the value of n comes to be 28. So the total number of terms between 200 and 400, which are divisible by 7, is 28. Now we have to calculate the sum. So the formula for finding sum is Sn equals to n by 2 a plus an. When the last term is given, then we can use the formula n by 2 a plus an, and total number of terms, that is 28 by 2. The first term is 210 and the last term is 399. So it goes by 14 into 399 plus 210, 9 plus 110, 3 plus 2, 5 plus 1, 6. 609 multiplied by 14. 609 multiplied by 14. 8526. 8526. Sum of all the numbers between 200 and 400. 87, 399 plus 210. 9, 9 plus 1, 10. 3 plus 2, 5 plus 1, 6. 609 into 14. 906 8526. The first number is 29 into 7. The first number 13 into 7. 207 divided by 7. 200. 204 divided by 7. 207. 20 into 7, 210, and 29 into 7, 203. So the first number will be 203. The first number will be 203. So the value of A is 203. So 203. This is 203. And 399 minus 203. We get 6, 9, 196. And 196 divided by 7. 196 divided by 7. We get 7 into 2, 14, 28. And the value of n comes to be 29. So 29 by 2. The value of n will be 29. So 29 by 2. And the value of A is 203 and AN is 399. So 29 by 2. 9 plus 3, 12. 0, 602. It goes by 301. So 29 into 301. 301 multiplied by 29. 9278. 8729. The result is 8729. So all the numbers between 200 and 400, their sum, which are divisible by 7, is 8729.